Here I will show how we can use the calculator to solve a quadratic equation by finding points of intersection. The sample problem will be that we will solve negative 4x squared minus 6x plus 15 is equal to x minus 2. So in this method, I'm going to actually think of this single equation as two functions. I'm going to sort of break it up. I'm going to think of the left-hand side, the negative 4x squared plus minus 6x plus 15. I'm going to think of that as my y1. So I'll think of y1 as being negative 4x squared minus 6x plus 15. And then I'll think of the x minus 2 as a second function. I'll call it y2. And y2 is equal to x minus 2. And now what I'll do is graph both of these functions on the calculator. So I'll go to the y equals screen, and for my y1, I will type in negative 4x squared minus 6x plus 15. I'll press enter, and for y2, I'll type in x minus 2. I'm going to graph both of these functions simultaneously just by hitting the graph button. Let me check my window just to see where I am. I'm in the standard window, negative 10, 10, 1, negative 10, 10, 1. So let me graph. I see a parabola opening down, and I see a line with a positive slope, as expected. And I see that there are 2 points of intersection. I see a point of intersection in quadrant 3, and I see a point of intersection in quadrant 4. So let's find those points of intersection. To bring up the intersect command, we will go to the calc menu by pressing second and the trace key. And I see that the intersect command is the 5th option. I'll move down to it and press enter. And now the calculator asks for a first curve, then a second curve, and a guess. Well, I only have 2 curves that I'm working with, y1 and y2. And so for the first curve, notice it says y1 at the top. For the first curve, I'll just use y1. I'll press enter. For the second curve, notice it's automatically moved to y2. Good. I'll press enter. For the guess, I'm going to move my cursor left or right as necessary to bring it close to the point of intersection. I'm going to first find the point of intersection that's in quadrant 4. I'll move my cursor to the right. I want to get close to where I think the point of intersection is, and I'll hit enter that 3rd time. The calculator runs, and it's telling me that there's a point of intersection. And I'll round to 2 decimal places on both coordinates. 1.36 negative 0.64. Now there was a second point of intersection. So this would be a great time to pause, try this out on your own, and find the other point of intersection. So I will run through the process again, but I'm going to have to adjust my guess to get the second point of intersection. I will run the calc intersect command again. The first curve is y1. I press enter. The second curve is y2. I press enter. But now for the guess, I have to move my cursor to the left. In this case, to get near that point of intersection in quadrant 3. And now I've moved it close. Now I'll press enter. And so we have another point of intersection at negative 3.11, negative 5.11. But we're not done. Remember, what were we trying to do? We were trying to solve an equation, right? We were trying to solve this equation which had only x in it. We created, in a sense, a system of equations which has solutions that are ordered pairs. But the solutions of that original equation are only x values. So, the solutions of negative 4x squared minus 6x plus 15 is equal to x minus 2 would be approximately the x values of the points of intersection. So the solutions of that equation are x is approximately 1.36, negative 3.11, just the x values of the points of intersection. So that was how we could use the graphing calculator and intersections to solve an equation.